This is about operating system fingerprinting, OS fingerprinting. We are here in the main chapter of our lecture about weaknesses and targets. We have already discussed online reconnaissance, and we will a little bit continue with this now when we speak about this operating system fingerprinting. This OS fingerprinting is a method to determine the type and the version of the operating system that is used by the remote host, that's used by the host I want to attack. Of course, operating system, this is the basis of IT systems and applications that are run. So if you know what kind of operating system is used and what version is used, there is publicly known a list of vulnerabilities for this operating system. Each operating systems are very complex IT systems, so every of this operating system has a number of failures, and a number of exploits are known how these failures can be misused. So this idea of this operating system fingerprinting is to find out which operating system, which version is used, then to go to the public domain, public available databases to find out what are the weaknesses of this operating system, and then to use methods that are known to attack the system. So sometimes this operating system fingerprinting methods do not provide 100% guarantee to know exactly this is the operating system run on this computer and this is the version. But often it gives the direction, what type of operating system it is, and even then this is helpful if there is, we will see for fuzzy analysis, if you do not have a 100% correct answer, but if you have an answer with high probability to plan a subsequent attack. Let's have a look to some of the methods to find out, to perform this operating system fingerprinting, to find out what operating system is run on the remote system. And one of these methods is so-called telnet session negotiation. And the reason are the banners and the banner information. So the telnet session negotiation is a very simple but effective method to determine the remote operating system or service. What is done? Systems often respond with a special information message, and this information message is called banners, if they are inquired by telnet. You know, telnet is a web service, and it's used for connecting to remote computers. So if there is a contact done, a telnet message sent, system answers back to give telnet the information about operating system, about other important parameters, so that telnet can establish a useful and meaningful connection to the system. So these banners, so this information that are provided in the answers, they typically provide information also about the used operating system and services, and even more, they often provide version number. The idea is to make a good connection, to provide to the partner all information so that afterward he can use telnet in the most affordable way. But for attackers, this is a possibility to collect data about the remote system. For example, POP3 mail server is someone who can see from such a banner information what is used. So the banner information later can misuse to prepare an attack. Here is an example. For example, telnet Jupiter. This is a response, and then you see, welcome to SUSE Linux 6.2, processor i386, kernel information. So this is presented to the person that sent such a telnet command back. So with such simple way to send such a command, one gets complete information. In most cases, one gets complete information about the operating system, the version, and more information about the system. The designer of Telnet, they did it to help that the cooperation of the system can be performed on a very good way. But in wrong hands, this gives a lot of information about remote system, so one attacker can later on try to find out what are the weaknesses of Linux, what are the weaknesses of this 6.2, what are the weaknesses of that kernel, and then can take exploits. Often the exploits are available in the internet to attack such a system. With Telnest, with a command telnest host and port number, also other services, information about other services are provided. For example, about mail, Telnet Jupyter 25, and here is the answer. Send mail in this and this versions are used. So for an attacker, he can now see what are exploits for this send mail version, and he can apply later on this attack. One can hear FTP server. Here, for information to get about the FTP server. Here, this is a typical answer provided in the banner information to anyone who sends this command. So this operating system fingerprinting is quite simple to get really often precise information about systems. So if you are responsible for such a system as system administrator, you should consider what kind of banner information is sent out. You can switch off. It makes it more difficult to establish a connection, but you do not provide such information in such a simple way. Many port scanners also provide this operating system fingerprinting features. So what is the preventing measure? I just mentioned this. The preventing measure is you should customize the banners in a way that they do not provide all the information. So the best is to completely turn off this banner information or to modify them in order to hide some of this information that may be useful for attackers. Let's have a look to another method to perform operating system fingerprinting, that it's the TCP stack fingerprinting. TCP stack, TCP protocol, this is IP protocol, runs with a different, on top of the different operating systems. And for each operating system, this protocol stack is implemented in a different way. And so in some minor details, you see differences in the different implementation. And there are databases that show which difference gives a hint to the underlying operating system. So TCP stack fingerprinting is a method to determine the operating system of a remote host on the basis of investigating such small details in the response if a packet is sent. For example, because this TCP stack fingerprinting is based on this empirical database, this database needs to be updated. So there are databases, I show later some examples, which exactly say if there is a response in this way, then it's a Windows database, it's a Windows operating system. If it's responding to a certain message in this way, then it's in a Linux system. So the basic idea is the stacks of the several systems differ in details, in very small details, in unimportant details, but these differences help to get information about system health. So a typical way is to send a non-standard request. And then for the standard request, all needs to be the same in all systems. But if you send a non-standard request, then the different implementations react typically in different ways. So these responses can be carefully selected, and they provide an exact copy for such a fingerprint system. So the most popular tool for performing such TCP stack fingerprinting is Nmap, the Nmap tool. It's freely available. It's a port scanning software, and this port scanning software comes also with a fingerprinting functionality. Here are some examples how Nmap can be used to find out details of the underlying operating system. So if you send this command, then this package for example, to our system, then you get this information back. And here you see, this is our standard information, and here. There is an exact information what operating system is used, what are the details of this operating system. So sending one information, one package, one command, and you get such information about the operation system. You get back very detailed information about the underlying operating system. Here are some different fingerprinting methods in the web. You can find more and add more of these methods. For example, the so-called fine probe. Fine, you remember when a TCP connection, when the system wants to close a TCP connection, a fine package is sent. And so here, this sending a fine package can be used in the following way for operating system fingerprinting. One waits for the response. The correct behavior would be that there is no response. If a fine package is sent, that's information, connection is closed, stop. But in many implementations, for example, Microsoft Windows, they send back a reset. So from the reaction on sending a FIN package, you can see and you can conclude that's very probably that a Windows system is used. The Boggers flag blob. That an undefined TCP flag in the TCP header, you remember this, of a SYN packet, of a package that that is sent to establish a connection. Then Linus boxes prior to 2.035, they keep the flag set in the response. Other operating system resets this. So from sending different kinds of packages and collecting the information, the small details, the small differences, and after a while, it becomes more and more clear what is the system used on the host that later on should be attacked. There are more methods, for example, TCP ISN sampling, find patterns in the initial sequence number, the ISN, chosen by the TCP implementations when they respond to connection requests. So you remember the sequence number helps that TCP is able to provide the packages, to bring the packages in the correct order. So, and the way how this mechanism is implemented, how the initial sequence number is selected, how the steps are done, this is different done for the different operating system. The IP ID sampling is possible to use for fingerprinting an operating system. So the most operating system increment the system-wide IP ID value for each package they send. Other implementations use random IP IDs, and some other systems use as an IP ID the 0. In many cases, when the don't fragment bit is set. So a small detail and different responses in the different applications. And if you collecting this information, you get a good idea about the operating system that's used. TCP timestamp can be used for operating system fingerprinting. Here the idea is to check the sequence of the TCP timestamp option values. Sometimes the options are not supported by the systems, And in other operating systems, in other implementations, this is incrementally changed in the different frequencies. So from such small details, you can conclude to the corresponding operating system this stack is implemented for. Don't fragment bit is also a possibility to reveal information about the underlying operating system. So many of the operating systems set the fragment bit on some packets they send, but not all operating do this, and some do this under different conditions. To mention some more of the TCP stack fingerprinting methods. So the TCP initial window, check the window size on the return packets. So here are different reactions of the different implementations for the different operating systems. The acknowledgement value. One can check the sequence number of the acknowledgement package. Most implementations will set the acknowledgement, the sequence acknowledgement initial equal to the same as the initial sequence number, but other will set it to initial sequence number +1. So all this, collect all this information to get a picture over the operating system that's used, and then you know the weaknesses of this operating system and can try to misuse this. I will mention another scanning tool, the AMAP, the application mapper that can be used for TCP stack fingerprinting. The applications, of course, normally use standard ports to offer a certain service. If the service is configured in such a way that it's not using such a standard port, the application has to listen on other ports than on the standard ports. And some of the scanning tools can't determine the right service. So AMAP is a tool that's able to detect services even if they are not provided on the standard port. If they are provided a little bit in a hidden way on a non-standard port. And the idea is that's implemented by this AMAP that trigger packets are sent, and then the responses are compared against a database. I want to mention another method to find out the operating system that is run on the remote system. This is the TCP IP timeout detection. So only try to make a connection to a system and then observe how a system is reacting. Typically, the TCP timeout values are relatively loosely specified in the request for comments in the IP standards. And that's the reason if something is not standardized in a fixed way, then in the different application and the different operating systems uses in a different way. So also here in the most operating systems, they have own parameters for this TCP timeout. There is a tool, it's a ring, called ring, that uses this situation to identify an operating system. So it causes ring system causes timeouts, and then analyzes how the different systems are reacting. So the ring is measuring the delay between successive SYN, also information to establish a connection, and the acknowledgement that's sent back. So the procedure that's used, a SYN packet is sent to the target. This is done in every case if everyone, every application or everyone wants to establish a TCP connection. And then the target sends back the SYN acknowledgement segment. Then this SYN acknowledgement package is ignored. So the sender, the attacker, does not send back an acknowledgement. And then there is a timeout. So the other side is thinking package got lost, and then next SYN acknowledgement, the retransmission after a while. And now a system exactly measures the time that it's in between. So here the ring system can find out what is the timeout value, and from knowing the timeout value or measuring the timeout value, this system can conclude, the ring can conclude on the operating system, on the corresponding operating system. Let's shortly at the end speak also about passive fingerprinting. We remember all this method I presented were active methods, because the attacker sends some information, sends a SYN package or do something, and analyzes the response of the system he wants to attack. In the passive situation, he observes situation without coming into direct contact with the target system. So here, instead of sending a special packet to the remote target host and then analyzing the responding package, in the passive fingerprinting, the user sniffs all what's happening in the network. How this can help to get information about the operating system that's used at the attacker side, at the remote system. The operating systems, the different operating systems use different TCP stack implementation, so that the TCP IP flag settings may vary. So, for example, the initial time to live information, the initial packet size, the window size, the maximum sequence size. So what the attacker is doing with his or her sniffer is to collect information. What is the initial time to live in the packets? What is the initial packet size? And from this observation, one can conclude on the used operating system. So of course, also this is supported by tools. A tool here in this context is a POF tool. With a POF tool, one can fingerprint a system without interacting with the system one wants to attack. So with POF, only by observing network traffic, one can conclude on the operating system. The problem every time with the passive attacks is that the victim has no chance to see that there's an attacker who wants to attack the system. In case of active attacks, of active also recon, and of active then the system can see in the log files that there was a kind of interaction. For example, someone tries to establish a TCP connection and does not continue to measure timeout parameter. Of course, it's reflected in the log files, but this passive recon, of course, there is nothing to see. So also firewalls can't prevent this, because only the outgoing packets are analyzed. And this can be done from everywhere. So this makes this dangerous, this passive fingerprinting dangerous. Also, of course, the possibilities to receive information are not so well established like in the case of active reconfiguring. So this POF analyzes the parameters of the packets and compares the results against a database of a known operating fingerprinting database, and then can come up with the information what kind of operating system is used. For example, here is a signature can be explored. So you can see from such type of signatures that the Windows system, or such type of signatures that it is a Linux system. Starting, I mentioned that sometimes, although there are different methods for such operating system fingerprinting, sometimes one cannot come up with a 100% answer. So the approach of the fuzzy operating system fingerprinting is not to insist that at the end of this process an exact operating system is mentioned, but an answer says it is highly probable that such system is used. So the use of such fuzzy matching systems is to correlate the received results also with a known fingerprint signature database, and then to come up not with yes and no answer like the traditional methods we discussed up to now. In the traditional methods, the answer at the end is it is exactly this operating system with this version, or I have no answer. Although a lot of information was collected. So the idea of this fuzzy operating systems is that one even provides information to the information about the used operating system in case if it's not 100% secure. So the accuracy can be influenced by different things, by the network topology, by the configurations of the network. So all what I showed you can sometimes work well, and in other connections it cannot work so well. And reasons are, for example, here that the yield value of packets, they can be changed by filtering devices. They can be influenced by the administrator and some of the configuration. Dropping or rerouting of packets can be caused by load balancing systems and others. So the TCP stack can be tuned in a system, so not the original version is used, but the tuned version, and so behavior is different in some points. So that's the reason that such traditional methods often do not come with an answer, because they are considered to provide correct answers. So the idea of this fuzzy operating system is to give at least a hint what kind of operating system is used, and a tool that works exactly on this idea and basis is XProbe 2, and this uses fuzzy matching system to identify this operating system. So this XProbe 2, for example, is based on a simple matrix representation of the scans. And then there is a calculation of the matches. So for each of these properties, for each of this hint, there is a representation. This detail could give the answer that that's operating system or that's another operating system. And then such a matching is done. And scores are evaluated. So score values, for example, in the form yes, that's a 3 score, or probably, that's 2 score, or probably no, that's 1 score, or not. So instead of only say yes or no, here we have a kind of voting which gives at least a hint what kind of operating system is used. So and then at the end, the operating system with the highest total score, this will be declared by XProbe 2. This will be declared as a final result and given as an answer, for example, to an attacker or system administrator. So you see, it is possible by careful observing the reaction and the behavior of a system that's connected over the internet with other systems. It is not so difficult to find out information, details about the systems, the operating systems that's used. We will later, and we saw already that also about the topology and other information, it's easy to get. So the attackers have a good chance to prepare an attack by carefully finding out as much as possible information about the victim systems later on they want to attack. So in the next lectures, then we will start to discuss the different attack methods and the reasons why they are useful.